Hello? 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 Ah. Okay, good afternoon all. What is the previous topic? Name, pointers. Arrays and pointers, right? How to access the array? By using pointer. We can use the name, right? We can use the name of the array. Okay. Name of the array is nothing but the first element of the array, right? And this program is also completed, right? Okay. Here we have the name, use name of the array, and that what is the second one? Expression. We have used the pointer, right? We have used the pointer here, P. That is, okay. A is assigned to star P, right? Name of the array is assigned to pointer. That means next one, pointer arithmetic. Just note on the heading. That means what type of operations we can perform by using pointers. Pointer arithmetic. The previous one is just name of the array. With that we can access the first element of the array, right? How to access the remaining elements of the array? How to access the remaining elements of the array by using pointer. By seeing diagram, we can easily understand. As usual, the name of the array, we can using array name or we can use pointers, some basic operations, that is addition, subtraction, about their indexes only. A, when we use name of the array, as we know, it points to the first element of the array. A, name of the array. If I want to access, that is A plus 1, second element, A plus 1, A plus 2, A plus 3, A plus 4. And if I use pointer, P is a pointer here, P is a pointer. If pointer is pointing to second element, Kakinada. 450. 5 की क्लास 450 क्लास అయిపోయింది ఎంత టైం పడుతుంది 130 చూద్దాం మన క్లాస్ 430 450 3.5 hours వీళ్ళకి ఇప్పుడు 3.5 hours కూర్చుంటా ఇవాళ కారం లేదు నేను రేపు వెళ్ళాడు మిగతా వాళ్ళు రేపు ఇవాళ నేను రేపు okay when you see the diagram you can easily understand A, that is name of the array, first element, right? A plus 1, A plus 2, directly we can use those things in program, right? Printf percentage D, A or A plus 1 or A plus 2. And when we use pointers, for example, if the pointer is pointing to second element, if second element, how to access the previous one? That is P minus 1. P minus 1. Next element, go to with addition, P plus 1, P plus 2, right? P plus 1, P plus 2, P plus 3, like this. Previous one, P minus 1, right? For example, if this is P, then it becomes P minus 1. If this is become P minus 2. This one becomes P plus 1, P plus 2, for example. Right? Directly we can write the programming statement, printf, just declare the array and write the printf statement. A of 1, A plus 1, A plus 2, A plus 3, or declare a pointer, okay, assign the name of the pointer to the, that means A is assigned to P, right? In the beginning we have talked about, right, the type of the data type. If the data type is integer, if the data type is, for example, character, if the data type is float, what happens? Right? Okay. A plus 1. For example, A of type character. Just note this diagram. Right? If the pointer is pointing to integer, if the pointer is pointing to character, if the pointer is pointing to float value. For example, here the pointer is pointing to character type, pointer is pointing to integer type, pointer is pointing to float type, right? Character means only one byte, one, like 100 plus 1 plus 1 plus 1. And when it comes to integer, 4 bytes are required. For each element, 4 bytes of memory is required. That means 100 plus 4, okay, 104, 104 plus 4, 108, 108 plus 4, for example, 112, right? First element, second element, third element. And when it comes to float, the memory allocation is 6 bytes, right? That's why 100 plus 6, 106, 106 plus 6, that is 112, plus 6, like that, 180. How to access that one? Same, a plus 1, a plus 2. To access the members, to access each and every element of an array, right? A plus 1, a plus 2. B plus 1, b plus 2. C plus 1, c plus 2. Just declare an array and write the printf statement, simple printf statement for understanding that particular concept. If you want to print the address, the conversion code is %p. Okay, like %d, %f, %c, %s. When it comes to strings, we use %s, right? For pointers, %p. What it is called? Conversion code, conversion codes. Just note this: char of a of 3, int b of 3, float c of 3 for these diagrams. If these statements are there, how the memory is allocated and how to access the members. For every concept, you write small program to understand that concept, how it works. A simple program: declare an array, write the printf statement. Declare an array, printf statement. Or if you want to take the help of pointer, just assign the address of that particular array to the pointer. Finish? కాలేదా? Character means 1 byte, integer 4 bytes, float means 6 bytes, 6 locations, that's why. 1, 2, 3, 4 like that, plus 6, plus 6, plus 6. These are important. B plus 1, B plus 2. When we use the name, that means indirectly it is pointing to the first element. Name of the array, indirectly first element of the array. Then to access the next one, B plus 1. Previous one, minus, use the minus. B minus 1, B minus 2, for example. Here, dereferencing by using star operator, indirection. Just note this diagram. We can access by a of 0 or star of a plus 0. Or pointer. 3 ways we can access. Directly using the concept of arrays, then indirection operator, then arrays. By using arrays. Star of a plus 0, star of a plus 1, star of a plus 2. Star means value, right? No. Star means value. Value where that pointer is pointing to. Star of a plus 0. Or otherwise the same previous concept, a plus 1, a plus 2, a plus 3, a plus 4. For this statement, simple statement, int a of 5, For each and every line, for each and every definition, we can write a simple program. Then only we can understand how it works. A of 0 or star of A plus 0 or A. A of 1, star of A of 1, A plus 1 or A plus 1. Finish? Arithmetic operations in other ways to access. Some of the examples: P plus 5 or 5 plus P minus 5, P1 minus P2, P plus plus, minus minus P. Just declare an array and write so many printf statements. Kada oka single program lone ivanni expressions rayanడి. Write many printf statements. In that write all these expressions. How the value changes, what we are accessing. Try to understand the output. We can use postfix also. For every statement you write a program. Just declare the array, write the printf statement. In that printf statement, write expressions. P plus 5 or pi 5 plus P or P minus 5. But declare a pointer. Assign the name of an array to the pointer. Then pointer logically points to array. The previous topic, previous example program. It will be very interesting if you write all statements. Try to execute that one. When we execute the programs only, then only we can understand the concept, how it works. Otherwise, we can't learn. We need to by heart. That is no use. Finish? Then about relational operators also, greater than or equal to or less than or equal to, we can also use that one. Same type, that means if the pointer, one pointer is pointing to integer, the another pointer is pointing to character, two different types, we cannot perform the operation, right? Remember that one. The relational operators, that is less than and equal, are allowed only if both operands are pointers of the same type. Two pointers of same type, integer, two pointers of same character, two pointers of same float. There is no combination. You cannot compare integer to float, float to integer, or float to character, or character to float of pointers. Declare two pointers and assign some addresses, then write the expression. Just printf statement, printf %d expression. P1 is greater than P2, or P1 is greater than or equal to P2. P1 is not equal to P2. What will get? Just same programs, write a program, small program. Just declaring an array and star number in direction. Value where pointer is pointing to. Star of number plus 1, star of number plus 2. Star of numbers, that is the first one, name of the array. That's why 25, then number plus 1, 50, number plus 2, 75. If you write number plus 3, we'll get 100. You must practice all programs, you must understand concepts. Then we can move to the next level. That is very important. For that we must be perfect with basics, otherwise no use. Once you learn the concepts, then start writing programs for the problems, bigger problems. Same program by using pointer, just notes. For previous topic, right? PTR plus 1, PTR plus 2, PTR plus 3. Previous diagram ఉంది కదా, for that example. Just declare the array, initialize it, and give the name of the array. Assign the name of the array to pointer. Assigning name of the array to pointer. That means pointer is pointing to the first element. star PTR of I, that means star PTR of 0, plus 0, plus 1, plus 2, plus 3, like that. Okay? For that we have used for loop. Otherwise, without for loop, we must write all printf statements individually. Individually means star of PTR plus 0, PTR plus 1, PTR plus 2, PTR plus 3, like that. If you take the help of for loop, just write single statement. If the work is repetitive, then take the help of loops. Output is just displaying all the elements, right? 25, 50, 75, 100, all. From 0 to 3, I equal to 0 to less than 4 means 3. This is 0 index, 1 index, 2 index, 3 index. This point is important. This one is important. This one is important. Assigning the name of the array to the pointer. That means pointer is pointing to the first element. Same previous diagrams unnai kada. Example program. Next one, memory allocation functions. At the time of variables, at the time of arrays, we have discussed, right? How the memory is allocated to each and every object in a program. The memory allocation can be in two ways: static memory allocation, dynamic memory allocation. Static and dynamic. What do you mean by static? At the time of declaration, whatever we declare, the memory must be allocated. And when it comes to dynamic, dynamic means, remember, runtime, execution time. At the time of execution, that is called dynamic. C gives us two choices when we want to reserve memory: static allocation and dynamic allocation. Finish? For example, arrays to discuss some with two types of arrays we can create. That is fixed length array, variable length array. Two types of arrays will be there. Fixed length array. Second one is variable length array. Fixed length means the size is known in the beginning, for example, then declare it. The other way, if the size is not known, how many number of elements are there? We do not know about that one. In that case, go with variable length array. The first one is fixed length, second one is variable length. A of 10, the size is known. 10 elements, I want to work with 10 elements. That means integer type means 10 into 4. For each integer 4 bytes, 10 into 4, 40 bytes of memory will be allocated for the first statement. But when it comes to second statement, the size is not there. We did not mention the size. Unda size em ledu. It can be 0, it can be 1, it can be 100, or it can be 1000 also. So at the time of execution, memory will be allocated for second statement. It is called dynamic memory. Variable length array, the dynamic memory allocation. Kada gurtunda? Arrays no. A of 10, B of nothing. Dynamic memory allocation. Heading and definition. This topic is very important, dynamic memory allocation. In examination, they will ask about this question. Discuss dynamic memory allocation function with example or something like that. Total 4 functions are there. Dynamic memory in C language. In C language, 4 predefined functions are there. Predefined functions. The language itself provides functions. Their names are malloc, M-A, all are small letters without spaces. M-A-L-L-O-C, C-A-L-L-O-C, R-E-A-L-L-O-C, reallocation. Free, the fourth one is free function, F-R-E-E. Malloc, calloc, realloc, free function. At the high level of programming, or we have the next data structures will be there. For most of the data structure topics, we use this topic only, dynamic memory allocation functions only. At the next level. That's why very important. Dynamic memory allocation functions are very important. In bracket, write these names. M-A-L-L-O-C, all are small letters, don't give spaces. M-A-L-L-O-C, C-A-L-L-O-C, and R-E-A-L-L-O-C, and free function, F-R-E-E. The first 3 are different ways to allocate memory. The fourth one is that what the name says, free. Freeing the memory, releasing the memory. Right? When should we release the memory? When the task is completed, job is completed, then we need to release the memory so that other jobs can take that memory. And when it comes to exams point of view, when you are perfect with basics, then you can write, you can answer any question. If you are unable to answer any question, means we are not perfect with basics concepts. మనకు బేసిక్ కాన్సెప్ట్స్ తెలుసు అంటే ఏ క్వశ్చన్ అడిగినా మనం రాయగలము కదా. రిమెంబర్ దట్ వన్. If you are perfect with basics, fundamentals, concepts, we can answer any question mostly. When we are unable to answer, means we are not perfect with basics. That's why I am concentrating. Just try to understand the concepts. Practice more and more programs. A simple program, small program. 2 lines, 3 lines program, 4 lines program. Nothing more than that. You write this also. Malloc, calloc, realloc and free. We will discuss in detail. Finish? Very important topic, dynamic memory allocation. Okay. Generally, for any programming language, first of all, we'll learn about the programming language, right? At the next level, we must have we'll be having the data structures. Remember that one. Data structures. Data structures is very, very important. Why? For all real-time problems, you can find solution with the help of data structures only. Through data structures concepts only. Right? At the next level. If you are perfect with data structures, we can write any programming, any program for any problem, for any concept, any idea. If some idea is there, we can write the program. If I have the concept, we can write the program. If I have a problem, we can write the program. When we are perfect with the data structures, the fundamentals of programming language and the concepts of data structures. The same diagram form, memory management, malloc, calloc, realloc and free function. Realloc and separate cheyakandi. Don't give spaces. Just rough ga draw chesesandi మీ own ga. These 4 about dynamic memory only, not static. Finish? The first one, malloc. Note this, malloc, MLLOC function, block of data, block of memory, remember that one. Allocation of block of memory. Whenever we talk about computer system or machine, we always work with, use this word, block of data. Okay, that block size can be anything. That depends on the operating system or problem. The block size can be 32 bits or 64 bits or 128 bits or 256 bits or 512 or 1024, like that. Okay, block of data ante. General గా కంప్యూటర్స్ లో ఏమంటాము, బ్లాక్ ఆఫ్ డేటా అంటే 2 to the power of n లోనే క్యాలిక్యులేట్ చేస్తాం కదా. 32, 64, 128, 256, 512, 1024, 2056, like that one. Okay, number of bits or number of bytes, block size can be. The malloc function allocates a block of memory, remember that one, that contains the number of bytes specified in its parameter. It's the syntax, void star malloc in bracket size t of t, size t of size, it underscore right, size underscore t space size. Size t, size underscore adi, hyphen kaadu, size underscore t. It is a special type when we want to work with large amounts of data. There we use the size t, size underscore t. Description ikkada undi chudandi, note down this one. The type size t is defined in several header files including stdio.h. The type is usually an unsigned integer. It is related to unsigned integer. Very big memory, maximum memory we can use. Unsigned integer, and by the standard it is guaranteed to be large enough to hold the maximum addresses of the computer. Regarding size t, what is the meaning of size t? Type. Generally we never use that one. Size t use chestama, int character float use chestamu, size t use chestama. That depends on the computer system. Maximum addresses of computer. Maximum address of computer means if you use RAM, 1 GB RAM, so maximum addresses will be there for 1 GB. For 2 GB, maximum address differs. Okay, 2 GB, 4 GB RAM, 6 GB RAM, 8 GB RAM, 16 GB RAM, 32 GB RAM. Their addresses changes, right? When main memory capacity changes, addresses also changes. Address limitation, maximum addresses. 32 GB RAM means very big memory, large amount of memory is available. This is the syntax, void star malloc, only one parameter, size t of size. Finish? Exam point of view, this topic is important. Generally they will ask question. Explain dynamic memory allocation functions. Example. Example, right? Some sample code. And when it comes to dynamic memory, that special memory location we use for that. Its name is called heap memory. Right? Heap memory. Some unused memory. From that we can use for dynamic memory allocation. Whenever we use dynamic memory allocation, okay, we will use this area, heap memory. HEAP, heap memory. Some reserved memory, what we call reserved memory, reserved for memory allocation functions. Reserved unused memory allocation, memory locations. You remember this word, heap memory, heap, HEAP. Heap memory is a reserved memory, reserved for these functionalities, malloc, calloc, realloc, free functions. HEAP. Next one, contiguous memory allocation. Whenever we hear about contiguous word, that belongs to arrays. Kada? Contiguous memory allocation anaki manaki em gurtuku ravali? Arrays gurtuku ravali. Continuous memory locations. That first function, block of memory. Second function for arrays, contiguous memory allocations. గుర్తుపెట్టుకోండి. malloc, block of memory. calloc, contiguous memory allocation. Contiguous means arrays, right? Related to arrays. Only for the purpose of arrays, we use calloc function. పోయిందా? Okay, make it fast. The first parameter is the count, total number of elements. 200 elements or 300 elements or 400 or 500 or 1000 elements, array elements. calloc always related to arrays. And malloc function without arrays in general. malloc, block of memory. calloc, contiguous memory. Two parameters are there. Size t of first one is element count, second one is element size. Size underscore t. Don't write hyphen, just underscore, that is without spaces. Size underscore t. Just note this diagram. For example, pointer pointing to one particular address, continuous memory locations. Pointer is pointing to the first element of the address, then we can store all 200 integers of array type only. Please note down the diagram also. Diagram and some sample code also. You write it completely, no problem. Later you search in Google, C program on malloc, C program on calloc. A small program will get. Execute it. Note the program and execute it. Just అది గుర్తుపెట్టుకోండి. malloc అంటే బ్లాక్ ఆఫ్ మెమరీ, రైట్? calloc అంటే contiguous memory. Contiguous means array, related to array. For every feature, for every functionality, remember syntax is very important. Writing syntax, the purpose, definition, syntax and example or any program. Third one, reallocation function. Generally, we must not use this reallocation. Reallocation means modification, right? Perlone undi kada, reallocate, malli allocate cheyadam. If it is sufficient, if it is insufficient, whatever the existing allocation is there, if it is insufficient, then allocate more memory, reallocate. Reallocate changes the size of the block by deleting or extending. By deleting or extending. By deleting means, for example, 50. Consider 50 bytes are there. We don't want 50 bytes. We want only 25. Modification. That means remaining 25 will be deleted. Remaining 25 will be deleted. Okay, existing is 50 bytes are there. We want 100. Again add to the existing one. Again add 50 more. ఎక్కువ ఉంది అంటే తీసేస్తాం, సరిపోవట్లేదు కొత్తగా యాడ్ చేస్తాం. సింపుల్. రీఅలొకేట్, పేర్లోనే ఉంది కదా, మళ్ళీ అలొకేట్ చేయడం, రీఅలొకేట్ చేయడం, సరిపోగలేదు. Void reallocate, REALLOC. Two parameters are there. One is pointer, the second one is new size. Void star pointer size t of new size. And in C language most famous is void, right? Void అనేది రెగ్యులర్గా యూజ్ చేస్తాం. ఇంట్ మెయిన్ ఆఫ్ void ఆర్ void మెయిన్ ఆఫ్ void అని రాస్తాం. If memory cannot be extended, extend చేయడానికి పాసిబిలిటీ లేదు, అప్పుడు ఏం చేస్తాము, ఆ ఎగ్జిస్టింగ్ వదిలేసి కొత్తగా ఫ్రెష్గా మళ్ళీ అలొకేట్ చేస్తాం. ఫిఫ్టీ బైట్స్ ఉన్నాయి, మనకు 100 కావాలి, ఆ కంటిన్యూస్ ప్లేస్ లేదనుకోండి, ఈ 50 తీసేసి మళ్ళీ ఏదైనా ఎక్కడైతే 100 బైట్స్ ఎక్కడ ఉన్నాయో ఆ మెమరీ అలొకేట్ చేస్తాం. That's the point. If the memory cannot be extended because of other allocations, reallocation function allocates a completely new block, new area, copies the existing memory. Existing data ఉంటుంది కదా, అది as it is కాపీ చేస్తుంది, existing location to new location. Data will not be lost. Note the syntax also. Generally in C language, void type is nothing but no specific type. ఏమని చెప్పొచ్చు? No specific type, no particular type. It can be any type. It can be any type. Anything can be accepted. Any type can be accepted. That's why we use most of the time we use void type. Kada? Int main of void or void main of void and rastam chala varaku. Finish? Just note the diagram. Next. Just note the diagram. Example, this. PTR is assigned with reallocate of PTR comma 15 into size of int. 15 is the number of elements. Right? Existing we have only 10 integers. Right? Existing only 10 integers are there. I want to extend it from 10 to 15. 10 to 15. Extension. That's why we have mentioned, okay, 15. Previously it was 10. RELLOC, don't give spaces, please don't give spaces. Bracket की function की मध्य में इकड़ा space इవ్వకండి. ఇక్కడ చూడడానికి space ఉంది. Don't give spaces. Previously it was only 10, now it is 15. The statement is important. Example statement. How to write that one? PTR is assigned with reallocation. PTR comma 15 into size of int. If it is int, then give int. If it is float, size of float. If it is character, size of char. Right? Integer, if it is integer, int. If it is float, give float, size of float. If it is character, size of char. malloc, calloc, realloc. Malloc, block of memory. Realloc, calloc, contiguous memory, arrays. Reallocation means updation, modification. Modification of previous memory allocations. It can be extension or it can be deletion. Finish. And the last one is that free function. As the name says, free means freeing up, releasing. Kada? Okay, once we want to execute a job, we require memory. We require memory. Once the job is completed, then what we need to do? Okay, whatever the memory we have borrowed, that must be released. Whatever the memory we have used, that must be released, so that other jobs can take that memory locations. అంతే కదా, మన వర్క్ అయిపోయింది, మెమరీ రిలీజ్ చేస్తాము, వేరే జాబ్స్ యూజ్ చేసుకుంటారు, వేరే టాస్క్. And the last one, void free of void star PTR. PTR pointer, or you can assign any name also. Example, before after, free of PTR, free of PTR. That means pointer is pointing to these memory locations. Remember, these are memory locations. Pointer is pointing to some memory locations, from this address to this address. Here free means after. When we execute this free function, free of PTR, that means all dashed lines. Dashed line means those memory locations are released. Now pointer is pointing to null. Null kada? ఏమి లేదు అంటే నల్ అన్నట్టు, NULL. డోంట్ యూజ్ జీరో. ఓకే, we must use that word null, NULL, all capital letters. For normal variable it is 0, the value is 0. For pointer it is null, NULL, initialization. Finish. Completed. ఇంకో స్లైడ్ ఉంది, పీడిఎఫ్, ఇంకో పీడిఎఫ్ క్లోజ్ చేయాలా? ఇక్కడే ఉంది పాయింటర్సా, ఇంకోటి అది పాయింటర్సా, ఇంకోటి ఉంది, ఇది డిలీట్ చేసేయండి కదా. స్ట్రక్చర్స్ అండ్ యూనియన్. బ్రేక్ తీసుకుందా? 5 minutes అవుతారా? బ్రేక్ 5 minutes బ్రేక్ ఇవ్వాలా? ఇక్కడే ఉంటుంది, తీసుకోమంటారా? Just 10 minutes break, okay? Stay here only. Okay, let us start the next topic. Next one, structures. Introduction to structures. Introduction to structures. Again, draw the first diagram. Enter the derived types are. What is the diagram? ప్రతి టాపిక్ మనం స్టార్టింగ్ ఒక డయాగ్రామ్ డ్రా చేస్తున్నాం చూడండి. డ్రా ఇట్. After this heading, introduction to structures, just draw the diagram. Derived types. In that we have function type, array type, pointer type, structure type, union type, enumerator type. Again, draw the same diagram, derived types diagram, all of you. Finish? Function type, array type, pointer type, structure type, union type, enumerator type. What difference is? Okay, leave the first one, function type. Next we have array type is there. What is the difference between variable? For example, okay, back and inka. Comparison. We can compare those four: variable, array, structure and union. Variable means to store the data, one single data. If you want to work with one single data, it can be any data, integer kaavachu, float kaavachu, edana kaavachu, single data element. We'll take the help of variable, regular variable. Then what about array? When we want to work with more number of elements, when we want to work with more number of elements, n number of elements of same type, 100 integers, 100 float values, 100 characters, 1000 integers, 1000 float values, then arrays is useful. We'll take the help of arrays data type, right? Then what about this third one? Comparison. Single element, n number of elements of same type, then structures is there. If I want to work with different data types at the same time, if I want to work with different data types at the same time, we want to treat as a single unit. We want to treat it as a single unit, right? In that case, we'll take the help of structures. For example, some student personal information is there. Okay, personal data is there, or for example, student record is there, right? What type of data we can have? Only one type of data, or different data types we can have. When it comes to student record is there. The name of the student, student hall ticket number. Okay, name of the student means array, character with arrays, right? And when it comes to hall ticket number or registration number, for example, integer. Okay, I want to store the details of marks, for example, subject 1, subject 2 marks. Okay, float values or integer values. Okay, I want to calculate the grade also, for example, grade of character type. Okay, percentage is there, CGPA is there, different data types, different data values. If I want to work with different data values and I want to treat it as a single unit, we'll take the help of structures. And then a comparison. And then a variable, single element. Here n number of elements of same type, 1000 integers, 1000 float values, 1000 clar. Okay. Then what about the structure? I want to combine different data types, different types of information, which is having different data types. And I want to treat it as a single unit. Then we'll take the help of structures, right? Adi gurtu pettukondi. Then what about union? Both are same actually. Structures and union both are same. Slight modification is there, small difference is there. Both of them are same. Structures and union both are same. The difference is that, okay, when it comes to structure, the memory is allocated individually. For all members. But when it comes to union, only whichever the member is having highest memories, ఏదైతే highest ఉంటుందో అది మాత్రమే యూజ్ చేయాలి. What we call shared memory, sharing. In union, sharing is done. In structure, there is no question of sharing అనేది ఉండదు. అదే డిఫరెన్స్. ఓకేనా? స్ట్రక్చర్స్ లో అన్నిటికీ ఆల్ ఎలిమెంట్స్ కి మెమరీ అలొకేట్ చేస్తాము. అదే యూనియన్ కి అయితే ఉంటుంది, అందరికీ మెమరీ అలొకేట్ చేయము. ఏదైతే మ్యాక్సిమం ఉంటుందో ఆ ఒకటే మెమరీ అలొకేట్ చేస్తారు. ఆ మ్యాక్సిమం మెమరీని అందరూ యూజ్ చేసుకోవాలి, 1 by 1 అందరూ యూజ్ చేసుకోవాలి. ఓకే, దట్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ స్ట్రక్చర్ అండ్ యూనియన్. ఓకే, స్ట్రక్చర్ ఎప్పుడు యూజ్ చేస్తాము, యూనియన్ ఎప్పుడు యూజ్ చేస్తాము? మెమరీ చాలా ఉంది, లాట్ ఆఫ్ మెమరీస్ అవైలబుల్, దెన్ విల్ టేక్ ది హెల్ప్ ఆఫ్ స్ట్రక్చర్. చాలా తక్కువ మెమరీ ఉంది. ఇన్ దట్ కేస్ విల్ గో విత్ యూనియన్, రైట్? That is the difference between variable, array, structure and union. Okay, note the definition. Today's modern applications require complex data structures to support them. For that, we'll take the help of structure. A structure is a collection of related elements, possibly of different types, having a single name, okate name, grouping different data elements under one name. For that we use structure. Structure and union same. Okay na? We'll see. రెండు సేమే. మెమరీ అలొకేషన్ డిఫరెంట్ అంతే. స్ట్రక్చర్లో ప్రతి దానికి మెమరీ అలొకేట్ చేస్తాము, యూనియన్లో అన్నిటికీ అలొకేట్ చేయము. షేరింగ్ ఉంటుంది, స్ట్రక్చర్లో షేరింగ్ ఉండదు. Okay, after this definition, just note the diagram. Example. Structure example. When we talk about fraction, okay, fraction in mathematics, it contains two parts, numerator and denominator. Or for example, student record is there, some information, student record, student ID, the name of the student and grade point or some marks, for example. All are different data. ID some number, name some characters, grade point some decimal points, float values, for example. This data related to integer, this data related to array with characters, this data related to some float values or any integer or whatever it may be. Note the example. Fraction is a structure, student is a structure which contains two parts, numerator, denominator, or ID, name, grade point. Finish? Next one, declaration. Like all data types, structures must be declared and defined. C has two ways to declare structure. One is tagged structure, type defined structure. Two ways to declare structures, that is tagged structure and type defined structure. Just note this syntax. Here we use the word keyword struct, S-T-R-U-C-T, struct. Struct is a keyword. Struct space tag bracket open some fields, field list or members. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . members, close bracket, semicolon. Example, structure, student. The name of the structure name is student. We want to create a student structure, student type. What we can say? Student structure type, which contains 3 members. Fields are 3 members. Char of ID, char of name, integer of grade point. The first member type is character, second member type is character, third member type is integer. Members antamu, fields are members. The best example student record ఏదైనా కావచ్చు కదా. స్టూడెంట్ రికార్డ్ అంటే రకరకాల different types of data వస్తుంది. When we talk about a personal single student, different elements will be there, different fields will be there. There we take the help of structures type. Struct student, struct space, the name of the structure, bracket open, and members. This is one format to declare a structure. Finish. Syntax, write the syntax and example. So how much memory is allocated for this structure? How much memory we need to allocate? Can anyone give the answer? How much memory to be allocated for a structure? For the first member, first member, char of ID 10. How much memory is needed? Total size is 10 of character type. For single character, 1 byte. For 10 characters, 10 bytes. For this, then second one, char of name of 26. Again, the size is maximum 26 of character type. That is 1 into 26, 26 bytes. Next, third one, third member, integer of grade point. Integer means for a single integer 4 bytes, right? Total enta 36 plus 4 40 bytes. 40 bytes of memory రాయండి ఐడియా కోసం. You'll get some idea. పక్కనే రాసుకోండి. Yes. For first member 10 bytes, for second member 26 bytes, for third member 4 bytes. Totally 40 bytes. Totally 40 bytes. 40 bytes of memory must be allocated. This is another type of declaration two types of declaration is there. Just write this one. Here we use the word type def without spaces. Type def. In previous one, struct, we use the keyword struct, S-T-R-U-C-T, struct. Here we use the keyword type def. Type def, struct, and fields. Type def struct, open bracket, fields, close bracket, then type semicolon. The second format is little confusing. Generally in standard books they use the second format only. For simple understanding, mostly follow the first one. Just note this, second also. Type def space structs, open bracket, fields, close bracket, and type semicolon. Example, same example, so student example. Type def struct, bracket open, char ID of 10, char name of 26, int grade points, 3 members. Okay, what we can say, fields of a structure are members of a structure. We can say field 1, field 2, field 3 are member 1, member 2, member 3. Members of student structure, fields of student structures. Field 1, field 2, field 3, member 1, member 2, member 3. Okay? Type def, the single word without space. Type def space struct. Not the example also. Finish? Next point. After a structure has been declared, we can declare variables using it. What do you mean by variables here? Okay, in previous we have declared a structure, right? Right, student structure is there. Student structure is there. Okay, if I want to work with one student, that previous declaration is enough. Previous declaration is enough. If I want to work with 2 students, 3 students, 4 students, if I want to store 2 student records, 3 student records, 4 student records, 50 student records, 100 student records. So what is the solution? We must create a variable. We must create a variable of that particular structure. Write it. After a structure has been declared, we can declare variables using it. Right here, student 1, comma, student 2, for example. In the beginning, we have created a student type. From that type, we can create variables, a number of variables. Struct student, bracket open, ID, name, grade points. 3 members. Okay? A terminology gurtupeట్టుకోండి. Members or fields అని చెప్పచ్చు. 3 members of student structure. 3 fields of student structure. Right? Okay, structure type created, then from that we can create a number of variables. We can create a number of variables. I want to create 1 student record, 2 student records, 3 records, 5 records, 10, 50, 100, 1000, right? So what is the meaning of this one? This is very important. Struct space student, student 1, comma, student 2, for example. How many variables are there? 2 variables are there. Student 1, 1 variable. Student 2, another variable. Student 1, 1 variable. Student 2, another variable. So what this student 1 contains? What this student 1 contains? Student 1 contains all the 3 members. Student 1 contains all the 3 members. Student 2, all the 3 members. This is the logic, right? When we have created 2 variables of student type, that means whatever the members of student are there, all those will be available in variables. All those will be available in variables, right? That means these 3 members will be available in student 1. These 3 members will be available in student 2. If student 3 is there, again 3 members. So how much memory is to be allocated for this? Memory allocation. For student 1, 40 general enta 10 plus 26 plus 4 kada 40 kada 40. For each variable 40 bytes must be allocated. 40 bytes plus 40 bytes. Inko variable undanukondi, again 40 bytes. Fourth variable is there, again 40 bytes. 40 plus 40 plus 40 plus 40. Right? Simple kada? Okay. How we can understand this one? Student 1 is a variable of student type, student structure type. Student structure type. Just note this one. Ila idu raskondi. 40 bytes. Student 1 40 bytes, student 2 40 bytes, all 40 bytes. కన్ఫ్యూజన్ ఏం లేదు కదా? స్టూడెంట్ టైప్లో 3 మెంబర్స్ ఎప్పుడు ఉంటారు, అదేనా? మనం ఎన్ని వేరియబుల్స్ క్రియేట్ చేస్తే అన్ని వేరియబుల్స్కి ఆ మెంబర్స్ అవైలబుల్ ఉంటారు కదా? స్టూడెంట్ 1కి 3 మెంబర్స్ అవైలబుల్ ఉంటారు. స్టూడెంట్ 2 3 ఫీల్డ్స్ అవైలబుల్. స్టూడెంట్ 3 3 ఫీల్డ్స్, లైక్ దట్. కంపల్సరీ ఫాలో అవ్వాల్సింది. Next, initialization, same as usual. When we create a variable, variable must be initialized, or we can read the value from the keyboard. అదే కదా మనం ఇప్పుడు స్టార్టింగ్ నుండి నేర్చుకున్నాం ఫస్ట్ చాప్టర్ నుండి. When we have a variable, it can be initialized or it can be, we can store the value by using keyboard, right? The same thing. Write it, make it fast. Write the statement. We can initialize a structure, same as variable, same as arrays. A variable must be initialized, an array must be initialized, a structure must be initialized, and union must be initialized. Normal procedure. You write this example. Then you write this one. Sample of SAM1 and sample of SAM2. SAM1 is a variable, right? SAM1 is a variable of sample type. SAM2 is a variable of sample type. How many members are there? 5 members are there. 1, 2, 3, 4. 4 members are there. We must follow the order, right? While initializing. While initializing, we must follow the order. The first one must be integer, second one must be integer, third one is a float value, fourth one is a character. SAM1 is initialized, first one is integer, second is integer, fourth one is, third one is float, and fourth one is character. Character is placed between single quote, right? On the previous session. String is placed between character and string difference. Character is placed between single quote and string is placed between double quotes. Previous topic, 1STYEAR. Here A is treated as character. Here A is treated as string. String. Right? Note this example. Make it fast. Ainda? Finish? SAM1 is a variable of sample type. How it is initialized? Like this. That order must be important, right? First member type enti, second member type enti, third member. At the time of initialization, only 2 values are available, right? Remaining 2 values are not available. Then filled with 0.0 and null character. Null character. Next one, accessing members of a structure. Accessing members of a structure. In the same way, accessing elements of an array by using index kada, we can access the elements of an array using index. In structure, we use the dot operator. Okay, don't make noise. Maintain silence. Okay, make it fast. Create a sample structure and create variables of sample structure. Then how to access that one? It is called SAM2 is a variable. SAM2.x dot operator. SAM2.x it is 7. SAM2.y it is 3. SAM2.3 0.0. Finish. Okay, maintain silence. Okay, all of you maintain silence. Okay, 5 minutes break this. Okay. Oh. Note down the example. How to access the members of a structure using dot operator. Using dot operator. Example note cheskunnara. For example, structure is there. Struct a sample of SAM1, SAM2. Two variables are there. SAM1 is a variable, SAM2 is a variable. Okay. For example, I want to access that one. That is X. This is through SAM2.X, SAM2.Y, SAM2.T, and SAM2.U. Okay. Dot operator. An example program. Write a C program. Write a C program. Write a C program to simulate multiplication of two fractions using structures. Multiplication of two fractions using structures. Like this format. For example, this format. In this format. First fraction 2 by 3, second fraction, for example, 3 by 4. The result must be, okay, that is 6 by 12. For that we need to create a structure. Struct a fraction, right? Create a structure fraction. It consists of two members, int numerator, int denominator. Close the bracket, semicolon. Outside of the main block, global declaration. Okay? What are the structure declaration is there? That must be global. Outside of main block. Here main block starts, right? Hash include std.h, then create a structure. Struct a fraction. Fraction open. Two members are there. Int numerator, int denominator. Member 1 numerator, member 2 denominator. చూడండి ఒకసారి జస్ట్ అవుట్సైడ్ ది మెయిన్ బ్లాక్ లోపల క్రియేట్ చేయలేదు. ఓకే, గ్లోబల్ డిక్లరేషన్. Note this format also. In this way we need to print. For example, ఇది ఒకటి జస్ట్ ప్రోగ్రామింగ్ లా అని పక్కన బ్రాకెట్లో some 2 by 3 into some 3 by 4 equal to 6 by 12. ఆ ఫార్మాట్లో అవుట్పుట్ రావాలి. Okay, first create a structure. Starting అయిపోయింది కదా. Create a structure. Struct a fraction of int numerator into denominator. Then main function, int main of void. Then create a variable, right? Variable 1, variable 2, that is fraction 1, fraction 2. Struct space fraction of fr1, fr2, that is fraction 1, fraction 2, res for result, right? Result. Fraction of fr1 comma fr2 comma res. fr1 fraction 1, fr2 fraction 2, res for result. Then read the values. Read the values for fraction 1, read the values for fraction 2, then multiply it. Multiply fraction 1 into fraction 2. Okay, first read the values. Enter first fraction in the form x divided by 5y. That is scanf percentage %d, here slash is there. How to read that one? fr1 dot numerator, dot operator. fr1 dot numerator. Then fr1 dot denominator. The 2 by 3, fr1 dot numerator, fr1 dot denominator. Then read the values for second fraction. Then for second one, second fraction. Enter second fraction in the form of x slash y. fr2 dot numerator, fr2 dot denominator, this one. fr2 numerator, fr2 denominator. Then multiplication. This is for multiplication, this is result. And then read the values for first fraction, read the values for second fraction, then perform the multiplication of two fractions, then display the result. అంతే కదా, 2 statements. A dot operator మర్చిపోకండి. fr1 dot numerator, fr1 dot denominator, fr2 dot numerator, fr2 dot denominator. After reading, you perform the multiplication. Result dot numerator, numerator this one. Result 1 dot numerator equal to fr1 dot numerator into fr2 dot numerator. Numerator, numerator. fr1 dot numerator into fr2 dot numerator. Result dot numerator equal to. Same result dot denominator regarding this one. Denominator, this. So fr1 dot denominator into this one. fr1 dot denominator into fr2 dot denominator. result dot numerator, result dot denominator. Okay, multiplication is completed. We have read the values for numerator, fraction 1, read the values for fraction 2, then perform the multiplication. After multiplication, whatever the result is there, just display the result. The last two statements. The result of percentage d by percentage d into percentage d by percentage d is, what is that first one? First percentage d. FR1 dot numerator, FR1 dot denominator, this one, this one. Then FR2 numerator, FR2 denominator. Then result dot numerator, then result dot denominator. And then confusion FR1 dot numerator, FR1 dot denominator, FR2 numerator, FR2 denominator, result numerator, result denominator. In this format only, reading in this format only. 2 by 3 into 4 by 5, like this. 2 by 3 into 4 by 5 equal to 8 by 15, 3 into 5, 15, like this. When we talk about fraction, it contains two parts, that is numerator, denominator. That's why we have taken the help of structure. We have created a structure. Variables idea anada, FR1 variable, FR2 variable, RES also variable. FR1 contains two members, FR2 contains two members, result contains two members. FR1 contains numerator, denominator, FR2 contains numerator, denominator, result contains numerator, denominator. Just return 0, output. Enter first fraction in the form x by 5, x by y, colon, some number. Then enter second fraction in the form of x by y, some fraction. Then the result of 2 by 6, it will be printed same, what are the values we have given. 2 by 6 into 7 by 4 equal to 14 by 24. Finish? And declare the structure globally. And then global ka declare cheyandi. When we declare a structure, create a structure, create it as a global one. Global means outside of the main block. Main block by processing. But when it comes to creation of variables, create the variables in main function. Next one, operations on structures. What type of operations we can perform on a structure? Same arrays node either topics unde. What type of operations we can perform on an array? assignment operation. Whatever the values of SAM1 is there, sample 1 for example, before and after execution of this statement, SAM1 is assigned to SAM2. That means whatever the values of SAM1 is there, all those are copied from SAM1 to 2, 1 to 2, 1 to 2. Before execution of the statement, these are the values. For example, 730.0 or 253.2a. After execution, the same values are there. The values of SAM1 are copied into SAM2. Assignment operation. This statement. And remember this point also. Same type. Same type means same structure. We cannot copy the data of another structure, one structure to another of different types. Structure 1 is different, structure 2 is different. We cannot copy like that. For this you can write a simple program also, right? Create a sample structure, create two variables, okay, and read the values, initialize this variable 1, variable 2, or you can read the values from variable 1, variable 2. Then perform the assignment operation. SAM1 is assigned to SAM2 or SAM2 is assigned to SAM1, like that. Same as previous program. Previous program is little bit confusing, not confusing, that format is different. Finish? After execution of the statements, the values are same. SAM1 values are copied into SAM2. Next very important topic is pointer to structure. Pointer to structure. To read the statement instructions line by line, we can understand what is the purpose of statement 1, what is the role of second statement, third statement, like that. Logically you think you can understand. Okay? Type def struct is there. We have created a structure which contains 4 members, X, Y, T, U. And that structure name is sample, right? Then some statements are there. Sample of SAM1, sample star PTR. Definition note cheskunnara. Just I will move upward so that we'll get the complete diagram. This topic is very important. How we can use pointers in structures. Pointers and structures combination. Pointer which holds the address of a variable, a pointer which holds the address of another pointer variable, a pointer which holds the address of structure. Logically okay? Correct enough? A pointer which holds the address of a normal variable, a pointer which holds the address of another pointer variable, that is pointer to pointer, right? Pointer to structure, a pointer which holds the address of a complete structure. Same logic. That means the pointer is referencing some particular area, structure area. That area contains some members. We can access members. Always accessing members. Storing and accessing. Storing, accessing. How to store, how to access. Note down the diagram also. You can easily understand. Note cheyanda, I will explain. Note this topic as important, right? Pointer structure and general very important. In real-time programs, we use this concept. Data structures, we use this concept. This is another way of declaration. Don't confuse. Type def, structure, int x, int y, float t, char u, sample. Then sample is the name of the structure. Then we have variables are there. Creation of variables. Sam1 is a normal variable of sample type structure. PTR is a pointer variable. Antena? Same. General concept use chesam. Normal variable, pointer variable. This is the same. Sam1 is a normal variable of sample type. PTR is a pointer variable of sample type. That means PTR understands sample type only. PTR understands sample type only. What this sample type contains? X, Y, T, U. That's it. PTR understands X, Y, T, U. PTR can access X, Y, T, U. Order. That you must maintain the order. The first member, second member, third member, fourth member. First member is X, second member is Y, third member is T, fourth member is U, like that. Fields are members. So what about this third statement, for example? Third statement. Sam1 is a variable of sample type. PTR is a pointer variable of type sample type. What we can understand this from this statement? Address of Sam1. Address of Sam1 is assigned to pointer. Right? That means pointer is pointing to Sam1. And pointer is pointing to Sam1. Right? ఈ స్ట్రక్చర్ అడ్రస్ పాయింటర్కి ఇచ్చామనుకోండి, మీనింగ్ ఏంటి? దిస్ పాయింటర్ is pointing to this structure, right? Whatever the address of this area is there, we have provided the address to this pointer. That means this pointer is pointing to this structure. Okay. Now PTR is pointing to this complete whole structure. Then how to access that one? Just note this. Manam star operator use chestam kada, the same concept. Star PTR dot x, this one. Star PTR dot y, star PTR dot u, star PTR dot t. Note this complete diagram. Two ways to reference. SAM1 dot x or star PTR dot x. SAM1 dot x or SAM1 dot y, SAM1 dot t, SAM1 dot u, or star PTR dot x, star PTR dot y, star PTR dot t, star PTR dot u. This statement is important, okay? PTR, sample star PTR. You have created a pointer which understands only the sample structure, no other structure. Sample name undi XYTU unnai, XYTU. For example, ఇదే పాయింటర్ ని మనం వేరే వేరియబుల్స్ కి యూజ్ చేసాం అనుకోండి, అర్థమవుతుందా? If you use the same pointer for other normal variable, అర్థమవుతుందా? It will not understand. That pointer will not understand. Pointer understands only sample structure. That structure must contain 4 fields. That's it. No other way to understand. Okay. Note చేసుకోండి, important. Star PTR dot x. మనం printf లో రాయొచ్చు directly we can write %d in bracket star PTR dot x, star PTR dot y, star PTR dot t, u, like that. Next, the same example, the other way to refer, the third one. Just note this one. Idhar రాయండి. Don't write this. Three ways to access, that is what we call direct selection, indirect selection. Indirect selection, that is hyphen and greater than symbol. Remember this one. In structure we use two operators. One is dot operator. The second operator is arrow, that is hyphen greater than symbol, combination. Pointers లో 2 operators యూజ్ చేస్తాము, స్టార్ ఆపరేటర్, యాంపర్సండ్ ఆపరేటర్. స్ట్రక్చర్స్ లో 2 operators యూజ్ చేస్తాం. ఏంటది? డాట్ ఆపరేటర్, arrow operator. Arrow is nothing but combination of hyphen and greater than symbol, without space. Remember this point. What we call dot operator is just a direct selection. When we use pointers, it is called indirection. When we use arrow, PTR, arrow x, the same meaning. The meaning is same. Right? If I write this statement, we are accessing this one. If I write this statement, we are accessing the same thing. If I write this statement, we are accessing the same thing. Same member. 3 ways to access. By using dot operator, by using pointer, by using indirect selection. That is arrow operator, arrow. మన కీబోర్డ్లో arrow ఉండదు. It is a combination of minus symbol, hyphen and greater than symbol. Space ఇవ్వకండి, don't give spaces. Continuous. Note down this diagram, very important. Write the same as it is. Direct selection, indirection, PTR arrow X. ఈ బాక్స్ ఏమి ఉండదు, కన్ఫ్యూజ్ కాదు కదా. ఈ బాక్స్ ఉంటుందా? బాక్స్ ఏమి ఉండదు, జస్ట్ PTR. PTR arrow and X like that. Here star PTR dot X. Here the same thing, SAM1 dot X. ప్రోగ్రామ్లో బాక్స్ ఏం టైప్ చేయలేము కదా, బాక్స్ ఏమి ఉండదు, జస్ట్ సపరేషన్ కోసం పెట్టద్దు. రైట్ ద నేమ్స్ ఆల్సో. దీన్ని ఏమంటారు? డైరెక్ట్ సెలెక్షన్ అంటారు. వెన్ వి యూస్ డాట్ ఆపరేటర్. వెన్ వి యూస్ స్టార్ PTR, that is indirection, indirect selection. 3 ways to reference the field X. Either X or Y or T or U, ఏదైనా కానివ్వండి. Right? For this, write a simple program. Okay, just create an structure, initialize it, and write the printf statement. Printf %d those SAM1 dot X, or printf %d star PTR dot X like that, or printf %d SAM1 arrow X, arrow X or arrow Y or arrow T or arrow U, any member. You can access any member of a structure. Okay, గుర్తుపెట్టుకోండి, స్ట్రక్చర్ క్రియేట్ చేసామంటే all are related together only, separate కాదు. X separate, Y separate, T separate, U separate కాదు. Okay, all are just like a family member of a structure. Remember that one. Treated as a single unit, treated as a single unit, no separation. Next one, nested structure. Nested statements, nested loops ఉంటాయి కదా. A statement inside another statement, a loop inside another loop, a structure inside another structure. Nested structure. Nothing new, same logic. We can have structures as a members of a structure. We can have more than 2, 3, 4 also, but it is very tough to access kada. In the same for loop lo kuda array lo 2-dimensional array, 3-dimensional array, 4 dimensions, 5 dimensions మనం జనరల్ యూజ్ చేస్తామా? అప్ టు 3 dimensions యూజ్ చేస్తాం. రైట్, ఇట్ బికమ్స్ వెరీ కాంప్లెక్స్. 4 dimension 4 loops, 5 dimensions 4 loops, but it becomes very, very complex. Here also they mentioned 3 only, 3 substructures. A structure inside another structure. Okay, first note the definition, then diagram. For example, stamp structure is there. Stamp, the main structure name is, what is that one? Stamp. Stamp structure అంటే ఏంటి? ఫర్ ఎగ్జాంపుల్ మనం డిజిటల్ సిగ్నేచర్స్ అంటాం కదా, అప్పుడు ఏం చేస్తాము? విల్ రైట్ ఆల్ ద డీటెయిల్స్, డేట్, టైమ్, ప్లేస్ ఇవన్నీ విత్ మినిట్స్ సెకండ్స్తో సహా చెప్తాం కదా. డేట్, మంత్, ఇయర్, వెన్ ఇట్ కమ్స్ టు టైమ్, అవర్ అండ్ మినిట్స్ అండ్ సెకండ్స్, రైట్? కంప్లీట్ డీటెయిల్స్. The same thing. The stamp structure contains two substructures are there. What are they? First substructure is date. Second substructure is time. Stamp structure contains two substructures. That is date substructure, time substructure. Again, this date contains three parts: months, day, month, day, year. And when we talk about hour, minute and seconds. And same next question, how to access? By using dot operator. Same way. Main is stamp, that's why first stamp. Then next reference is date. Then next reference is month. Main structure, substructure, then member. Stamp dot date dot month, stamp dot date dot day, stamp dot date dot year, stamp dot time dot hour, stamp dot time dot minute, like that. A dot operator. Yes, పాయింట్స్ గుర్తుపెట్టుకోండి. యారేస్ అంటే టూ ఆపరేటర్స్, స్టార్ ఆపరేటర్, యాంపర్సండ్. పాయింట్ స్ట్రక్చర్స్కి టూ ఆపరేటర్స్, డాట్ ఆపరేటర్, యారో ఆపరేటర్. యారో ఆపరేటర్ సింబల్ ఉండదు కదా, కాంబినేషన్ ఆఫ్ మైనస్ సింబల్ అండ్ గ్రేటర్ దాన్, వితౌట్ స్పేస్ ఇవ్వకండి. For every concept, just write a small program, okay, and try some variations. Why for variations? If you try some variation, we'll be knowing how the program is responding, what is the output we'll get, okay, whether we get the proper output or error, what type of error it is. In that way only we can learn programming, otherwise we can't learn. First we must be perfect with basics, then next level data structures, programming. Finish diagram. This is the creation, just write it. Declaration. First create first date, then time, then stamp. Stamp contains date, time, like that. Logical. Think logically. Okay. First of all, stamp is there, right? Stamp must contain date, then define date. Stamp must contain time, then define time. Okay, stamp must contain date and time. Where is the date? Where is the definition of date? This one. Then where is the definition of time? This one. Namings are very important. The identifiers must be same. Capital letter is different, small letter is different, case sensitive. What we call case sensitive kada? In C, capital letter is different, small letter is different. Whatever the name is there, we must maintain same as it is. Date capital letter, the capital letter usual. This date is a member of date structure. Time is a member of time structure. Time structure type అని చెప్పాలి. Structure type, pointer type, union type. Just like integer type, float type, ఇవి కూడా types. Here we can say date type. Date is a member of date type. Time is a member of time type. Time structure type. Time structure type. Then at the end create variables. What is this one? STAMP is a variable. STAMP is a variable of type stamp type. Stamp structure type. This is variable. Or you can write stamp 1, stamp 2, stamp 3, stamp 4. So many variables, a number of variables. At least ఒక 2-3 రాయండి, మనం కన్ఫ్యూజ్ కాకుండా. స్టాంప్ ఆఫ్ స్టాంప్ 1, స్టాంప్ 2, స్టాంప్ 3, సెమీకోలన్. Stamp 1 contains all the members. Stamp 2 contains all the members. Stamp 3 contains all the members. ఒక టాపిక్ ఉంది, యూనియన్. అర్జెంటా ఒక చిన్న టాపిక్ యూనియన్ ఉంది. జస్ట్ ఒక 5 minutes. Make it fast. Small example, right? Stamp of stamp equal to initialization. 3 values. The first one is about the date. Second one is about the time. Initialization. How to initialize? Continuation, no problem. Stamp of stamp 1, stamp 2, stamp 3. Then stamp of stamp 1 already. Initialize cheyandi. You must maintain the format. First about the date, second about the time. Just one statement, add one statement. Finish? లాస్ట్ ఒక టాపిక్ యూనియన్ రాయండి. యూనియన్స్ మేక్ ఇట్ పాస్. Just write. Structure and union both are same. Only memory allocation is different. గుర్తు పెట్టుకోండి అంతేనా? స్ట్రక్చర్ అండ్ యూనియన్ బోత్ ఆర్ సేమ్ టైప్. సేమ్ ఎలా ఏదైతే ఫాలో అయ్యామో యూనియన్ కూడా సేమ్ ఫాలో అవ్వచ్చు. ఇనిషియలైజింగ్, యాక్సెసింగ్ అంతా సేమ్. బట్ ఇంటర్నలీ మెమరీ అలొకేషన్ డిఫరెంట్. స్ట్రక్చర్లో అన్ని మెంబర్స్కి మెమరీ అలొకేట్ చేస్తాము. బట్ యూనియన్లో ఓన్లీ మ్యాక్సిమం దానికి అలొకేట్ చేస్తాము. అదే మెమరీని అందరూ యూజ్ చేయాలి, షేర్ చేయాలి. షేరింగ్ అదే డిఫరెన్స్. మెమరీ చాలా ఎక్కువ ఉంది, విల్ టేక్ ది హెల్ప్ ఆఫ్ స్ట్రక్చర్. మెమరీ చాలా తక్కువ ఉంది, then we'll take the help of union. That's it. ఒకసారి ఎగ్జాంపుల్ చూడండి, జస్ట్ 1 సెకండ్. ఇప్పుడు యూనియన్ స్ట్రక్చర్కి అయితే ఏం చేస్తాము? ఫర్ ఎగ్జాంపుల్ ఇంటెక్స్ అంటే 4 bytes. ఫర్ ఎగ్జాంపుల్ యూనియన్ అని స్ట్రక్చర్ అనుకోండి, 4 bytes. ఫ్లోట్ అయితే 6 bytes. 6 bytes. క్యారెక్టర్ 1 byte. టోటల్ ఎంత? 4 + 6 10 + 1 11 bytes కదా. ఇది స్ట్రక్చర్ అయితే ఓకేనా. యూనియన్ అయితే ఎంత మెమరీ అలొకేట్ చేస్తాము? మ్యాక్సిమం ఏది ఉంది ఈ వన్నిట్లో? 6 వల్ల ఓన్లీ 6 bytes మ్యాక్సిమం కదా. ఈ 6 bytes మాత్రమే అలొకేట్ చేస్తుంది ఓకేనా. నాట్ 11 bytes. ఈ 6 bytesని అందరూ షేర్ చేసుకోవాలి 1 by 1, రైట్? అదే డిఫరెన్స్, వేరేం లేదు. జస్ట్ నోట్ దిస్ ఎగ్జాంపుల్. ఒక చిన్న డయాగ్రామ్, జస్ట్ డయాగ్రామ్ వేసుకోండి లాస్ట్. జనరల్గా ఇంటర్వ్యూలో అదే అడుగుతారు, వాట్ ఇస్ ద డిఫరెన్స్ బిట్వీన్ స్ట్రక్చర్ అండ్ యూనియన్. ఓకే, స్ట్రక్చర్లో అన్నిటికీ మెమరీ అలొకేట్ చేస్తారు, యూనియన్లో ఓన్లీ మ్యాక్సిమం. ఆ మ్యాక్సిమం అందరూ యూజ్ చేసుకోవాలి, షేర్ చేసుకోవాలి.
you.